power functions are what we're talking about first in our next unit. So a power function is any function of the form f of x equals ax to the n. And think of it like n is your power, is your exponent. That's why it's called a power function. Okay? Where a cannot equal 0 and n cannot equal 0. Okay? So anything other than when a is 0, because that would equal 0, and when n is 0. All right? A power function is also a type of monomial function. Monomial means just one term. So we just have one term here. Okay? Draw a sketch of each of the following monomial functions. All right, and this is kind of like the same idea as a parent function. We're just drawing the sketch here. A monomial is one term. So we're really not adding or subtracting anything to it. Okay? So a constant happens when your function equals c. Your constant is c, and that can be any number, 5, 10, 15, 20, -5, whatever. It's going to be a horizontal line at c. Above the axis if it's positive, and below if it's negative. Okay, so c is just a number. All right, linear, drawing that parent function in function form would be f of x equals x. And that is your line through the origin, okay? And this is still a monomial function, okay? It's still a power function. In this case, if your f of x was x, and we want a x to the n, a would just be 1, and x to the n would just be 1. Okay, so this still counts as a power function. All right, quadratic. That parent function we should know by now. F of x equals x squared. It's going to be a u going through the origin. Cubic. F of x equals x to the third. So it's going to kind of snake up, and it starts decreasing, or sorry, it starts pointing down and increases through the origin and back up. It increases the whole time. All right, quartic is f of x equals x to the fourth. Okay, and that's going to have some kind of turning point if you don't have, like if you do have plus something, or if x happened to be a factor. Okay, but if there's not, it's still just gonna take on the shape of a quadratic. Okay, and in the same exact form, or the same exact idea, when you have a quintic, or quintic, however that's said, that means 5. It's still going to take on the same kind of shape as an x to the third. So you should see some sort of pattern between your even exponents and your odd exponents in the way the graph looks. Okay? All right, so symmetry. If the function has an even power, then what is its symmetry? Okay, well, if we look at our even powers and I fold them on the y-axis, that's where my symmetry line is, right? So then it is symmetric about the y-axis. And we already talked about this actually in the last chapter. Okay. And if we have an odd power, like x to the third and x to the fifth, it is symmetric about the origin. So if I rotate around the origin, I'm going to end up with what I started with. If I rotate, that's an origin symmetry. Okay? Then it is symmetric about the origin. And like I said, we already have talked about this, so hopefully that's just a review. Okay? So, in behavior now, these are still gonna follow the same idea for even and odd, okay? So whether your power is x squared, x to the fourth, x to the sixth, we should have the same in behavior for our positive and negative coefficients, okay? But we're just gonna start with what we know. We know what x squared is. So if we're on an even power and a positive coefficient, what's gonna happen to your in behavior is as x approaches infinity, y approaches infinity. And as x approaches negative infinity, y still approaches infinity, okay? So they're both, your in behavior is pointing up on both sides. And that, or what I mean by both sides is the left and the right side of your graph, okay? And that's gonna be true for any even power, even if it's x to the fourth, okay? For if you have a positive coefficient. If you have a negative coefficient, well, it's just gonna flip the way your graph opens. Okay, so your in behavior there would be as x approaches infinity, y approaches negative infinity, and as x approaches negative infinity, y approaches negative infinity, okay? Another thing to note is your in behavior for positive exponent should be the same on both sides. Same on both sides, okay? So yeah, if you have a negative even power, your in behavior is going to be pointing down all the way left and down all the way right. Okay? Oops, let me highlight the even too. Okay, and if you have an odd power, you really should be pointing opposite ways in your in behavior, okay? So, odd power, positive coefficient. Let's start with what we know. We know that x to the third looks like this graph, okay? So the in behavior, as x approaches infinity, y approaches infinity. As x approaches negative infinity, y approaches negative infinity, okay? So that means on the left side and on the right side, I have left is pointing down and right is pointing up. And that will happen for an odd power positive coefficient, always. All right, and then finally, odd power negative coefficient. It's just going to be the opposite of our positive in behavior. All right, so starting with what we know, negative x to the third. As x approaches infinity, y approaches, negative infinity. As x approaches negative infinity, y approaches infinity. So in other words, the left side should be pointing up now, and the right side should be pointing down, okay? So again, anything even, you're gonna have the same in behavior on either side. Anything odd, it's gonna be opposite, okay? All right, That's enough for the first page.